This is part 3 of the two-dimensional motion mock test, the adding the two vectors. My recommendation to you is have this page just in your pocket. That you can always do this page, and if you prefer not to, you don't have to on the test, but if one of the other pages doesn't turn out, this is a good fallback because it's very predictable. If you can do exactly what I'm going to show you, then you can do this page of the test, no problem. Okay, so we're going to add these two vectors, and what we do to add two vectors like this is we break them into x and y components, add the components, and then turn it back into a vector. Okay, the first step then is to find the trig angle that these things are at, right? And then this is our trigonometric circle, and the way trig angles work is they go anti-clockwise from the x-axis. So this might be 45 degrees, there's 90, 180, 270, and then all the way back is either 0 or 360. Okay, so this guy's trig angle, since it's pinned to 180 degrees, right? Here's the origin, the vertex of the angle is always the origin, right? That's 180 degrees there, and this is short of 180 degrees. We didn't make it to 180 degrees. We started here, we didn't make it all the way there. We stopped 62 degrees short of 180, okay? So this angle is going to be 180 minus 62, which is 118 sometimes, right? Okay, and then this guy here is pinned to 90. Again, the vertex is always 0, right? And so we didn't get to 90 degrees. In fact, we were such slackers that we stopped 58 degrees short of 90 degrees, right? Okay, so this angle is going to be 90 minus 58, which is 32 degrees, right? The rest of this can be done by robots. Okay, so here we go. We've got this first vector. It is 11 meters, and it's at 118 degrees. And then we've got 13 meters at 32 degrees, right? And we're just going to make a little table like this. And we're going to find x components, y components. Why? Because I love you. Okay, there we go. Now, all you do here, this is our magnitude, by the way. Here's our angle. All you do is you use cosine for this guy, sine for this guy, right? So 11 meters times the cosine of 118 is this guy. 11 cos 118. Again, you want to make sure you are in degrees, right? So go mode, or on this calculator it's second mode. Check that you're in degrees. Yes, I am. Okay. I'm getting negative 5.164 meters, and I'm carrying extra digits, a couple extra digits. I only have 2 here, really, but I'm going to carry 4. Okay. And then I'll go 11 sine 118. And this is 9.712. And this is just what we expect this vector to have. This angle is definitely an awkward angle, so it's got more of this, less of this. This is negative, so this is just what we expect. More y than x, and the x should be negative. Okay. This guy here we expect to have more x than y, and both should be positive. So let's just try it. 13 cosine 32 is 11.025. Okay. I guess 11.02 is what we'd stop at, right? Because we only need 4 digits, right? I'm going to put the 5 on there. I've got to do it. Okay. And then this guy is going to be 13 sine of 32, 6.88. It's 8889. So I'm going to say 6.889. Okay. So now we've broken these into components. To do this one, for example, is 13 cos 32. This one is 13 sine 32. And I'm typing exactly that into my calculator, hitting enter, I get the answer. Okay. Now I add this to this and get the sum. And I add this to this and get the sum. You can add x's and x's together and y's and y's. Don't add the x to the y or you'll get arrested by the math police. Minus 5.164 plus 11.025. 5.861. Okay. 9.712 plus 6.889. 16.601. Okay. So now we have the answer in vector component notation, but now we need to draw a picture of this, okay? So here's how I do it. I go over, and then from there, okay, this is this guy here, right? 5.861. And then I go up, and this guy's, 3 times as long as that guy, right? So I'm going to draw it longer, at least 16.601. And that way I know for sure this angle is bigger than 45 degrees because I drew it somewhat accurately. Okay? And now we need to find this angle. Okay? So this angle here is going to be the inverse tan of 16.601 divided by 5.861. So second tan, 16.601 divided by 5.861. And I get 70.554 degrees, and the sheet says 70.6 degrees. Okay. I'll go with that. That's 3 digits, I gave you 2. All right. And then the magnitude here, okay, this magnitude is going to be the hypotenuse, so it's going to be the square root of 5.861 squared plus 16.601 squared. So square root of 5.861 squared plus 16.601 squared, right parenthesis. Got to put parentheses around that. And it's 17.605 meters, which would be 17.6 meters like it says on there. Okay? So there it is. You have to draw this. You have to, when you draw this thing, make sure that you make the hypotenuse an arrow like that, right? That we know that you're starting here and going there, okay? Yeah. And then I wrote it in English, but that's the real picture. That's what it looks like.